Hey, it's me again. I can only record 10 minutes at a time because I'm cheap and I did not pay for the pro version of Screencast. Anyways, we were talking about radiation and how right up here we see that the dog, there are some parts that are giving off more infrared waves, like her eyes or her mouth, and those would be the parts that are hotter. You can even see on the thermometer over here, they're color coded. You can see which parts are radiating more energy. Now, other examples of radiation could be like anytime you put your hand up next to something and you just sort of feel its warmth, you don't feel the air moving, you don't touch it, that could be radiation as well. So when you're doing a picture or a symbol for radiation, I would always make sure you include these waves because the wave is important. It's a wave of energy. So if you guys start asking, well, what about this? Well, what about this? You might actually come up with some examples of conduction, convection, radiation where more than one thing is happening. Here's a great one. This one is conduction because the person is touching the handle. It's convection because the water is moving in a cycle, hot water rising, cold water sinking, hot water rising, cold water sinking. And it's also radiation because it's giving off these radiation waves. So if I put my hand over here next to the fire, I'd still be able to warm myself up because of the radiation from the fire. BrainPop also has a lot of good stuff on here. Feel free to look up some things about conduction, convection, and radiation on BrainPop when you got some time. So I wanted to ask why hot water rises, why cold water sinks. And this is going to be the back of your notes. And shockingly enough, it's all about density. So I'm going to shrink this down a bit so I can use a little pen here. And I'm looking at why these things happen. So let's take a look. This substance has 5 different particles in it. And over here it says each particle is 1 gram. So it's kind of like a symbol. So the mass of this one would be 5. Now, it says for the volume that each box is 10 milliliters. Each box looks like they're the same size. So each box is 10 milliliters. And I remember that density equals mass divided by volume, which says right here. Don't laugh at me about this pen work. It's actually a lot harder to use the touchpad than I thought it would be. Anyways, so 5 divided by 10, mass divided by volume. If you want to grab a calculator to do it, you can. I'm going to do this one for you, 0.5, which is a pretty low density number. And we know it's low density. We can see it's low density because the particles are spread out. Now, if you want to, you can pause it real quick and you can calculate the rest of these if you want. This one has 9 particles in it and it's got a volume of 10 milliliters. This one, oh, I don't even know how many there are in this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 7. I just counted 17. I might have miscounted. If I miscount, you can count for me and count it right. But it's still the same box, 10 milliliters. So yeah, pause for a second and calculate these on your own. You can use your Chromebook's calculator, or you can use a handheld calculator if you want. So when you do all the mass divided by volume, you find density numbers. Boom, 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 boom. Okay, so that's great. But what does it mean? What does it even mean? So I'm just going to erase all my stuff here. Give me a second so I can erase all of this. There we go. So anyways, looking down at the bottom, what does this all mean? Well, earlier we found out that when something has a high density, what does it do? High density does what? High density sinks to the bottom. So something like water, which has a high density, sinks to the bottom. Something like oil with a medium density would stay kind of in the middle. Something like rubbing alcohol, I might just put AL, because I'm not writing that with this little pen. AL, period. So something like alcohol, which has a very low density, floats to the top. Now, if I blew some air bubbles in it, you would notice that the air bubbles, which have a super low density, would float all the way to the top because high density sinks, low density floats. So we're going to go back to this. Here we go. High density sinks, low density floats. We remember that from density. And when things heat up, well, hot water has a lower density than cold water. Whoops. Hot water has a low density. Cold water has a higher density. So that makes a little cycle right there. Hot water rises, cold water sinks. Hot water is less dense. Cold water is more dense. Wait, hold up. Why is that? Well, it turns out that's something that we're going to be talking about, blah, 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 in our next set of notes. I may ask you to do them today. I may ask you to do them on another day, but that's the long and short of it. If you would be so kind as to make sure that you've filled out both sides of your notes today, because you are going to be asked to do stuff with it next class. Stay tuned for a little explanation of expanding and contracting, which we might be doing this way as well. Thank you so much. If you finish up, make sure you follow whatever directions you've been given for if you finish. Because if you're doing something else, then I'm going to be looking at you funny. So check your directions, find out what to do when you're finished, and I will talk to you later.